This will be a short tutorial that just covers, well, it'll cover power copies, but the main point of this is to look at rules. And the example that I have open here is, well, typically when we use parametric software, we're looking for a kind of seamless variation between the parts. And this is one example that I use where if we were thinking about lumber and spanning, we wouldn't want every piece to be a custom size. And so what I've done is I've created a rule based on how far something will span, which will set up how deep that member will be. And so we can see as we move across, we've got a range of a 2x12, 2x10, 2x8, and then 2x6. And so what I want to do in the tutorial is work through setting up the simple framework, setting up the power copy, but then embedding this as a rule within that, so we can see how that works. And just as a way to show how we'll set it up, we've got a sketch just with a couple of dimensions here. If we change this, we can see that each of these knows how long they are and then adjusts accordingly. And so here we can see when it meets the threshold, when it's no longer necessary to be a 2x10, it drops down. And then the same thing is true as it drops down over here. So we'll talk about how to set up that rule and then how to structure the power copy to make it so this works. So I'll close this. And we'll start a new part. So we'll say new part. And then be sure to enable hybrid design and create a geometrical set. And I'm just going to call this joists. So the first thing that we want to do is we'll set up our framework for our power copy. And so we can rename the geometrical set, and I'll just call it exactly that. I'll call it framework. And if we use the absolute axis system, this is something that we'll have to reference later. And so I often just hide this at the very beginning and imagine trying to structure my framework in a way that will not require that. Which means that I also try not to start at 0, 0, 0, just as a kind of best practice. So I'll start at x12, y12, just to get this off of the x-axis, or off of the origin, and say OK. And then all I really need are 3 points, which in this case I can set x to 0, y to maybe 225, which is our maximum span for 2x12. And then I can set x equal to, let's say 300 for now, just so that we get enough elements, and we'll say OK. So as we zoom out, we can see these 3 points in space. I can expand the framework. If we've got 3 points, then we can create a plane. And whichever point you pick first, that's where the plane ends up. Now we can create a sketch with this. And what I'll do is I'll use the construction geometry and project these points into my sketch so that I can reference them. And maybe I'll just make 2 lines. And I can even set this to have a construction line here and one here, and then I can make these coincident. And so I'll just double check this. That's 225. I can leave that as a reference, and then I can set this accordingly. Or I can also set it as a reference so that I can just control it independently in the sketch. And let's see, let's exit the sketch. I like to turn off the absolute axis for the individual sketches. And so since this is the line that we'll be using to set our power copies, the other line will become the line that we use to reference that. And so actually what I'd like to do is I just want to go into the sketch and create, just again for best practice sake, make each of these an output feature so that we don't have any problems about referencing them separately when we're outside of the sketch. So now we've got that. If we want to, let's see, let's create, well, now we'll just create a couple of points along this line. And so we'll do points on curve, select this, and we'll do distance on curve as 16 inches. And we'll repeat object after OK. And we don't want to create this in a new body. And we don't need to create normal planes in this case, but let's add 20. This may be too many. So here's a problem in that we want to do instance and spacing. We can do 16 inches, and now we see that that preserves the spacing and gives us the number, which is probably better like that. So we'll say OK. So now we've got a series of points that we'll use to insert the power copy, and these will span to this other line over here. So I'll minimize the framework, and I want to create a new geometrical set now. And I'll call this build geometry. It doesn't really matter which one I start with, but this will be the geometry that I use to create the actual power copy. And so we're going to start with a couple of points. I'm just picking one of these. I'll do it coordinates. And in this case, what I'll do, if x, we'll do x0. Maybe we'll just do z minus 16 and say OK. And I'll add another point right there to be y plus 16. And so given this one point, it's easy to imagine how these other 2 points are made just based on coordinates. Now that we've got 3 points, we can create a plane. And now that we've got a plane, we can create an intersection. And so the first element will be our plane. The second element will be our line that we're spanning to. So now we get a point on the other side. So as far as that's concerned, we can hide our first 2 points. And we're going to use our plane to create a sketch. But I want to do something first, which is to make 2 parameters. So I'll filter for user parameters, and Both of these will be type length. One will be joist underscore length. And so yesterday in class we had a realization, and we tested this, that if you put a dash, joist dash length, this will give it, you can see when we press apply, it gives it the single quotes around it because the dash is also a minus. And so it gives it the quotes to make it into a string. But if we do this again, we say joist underscore length or something else and say apply, we don't get those single quotes. So I'll probably be using underscore from now on. But the second one that I'll make is depth. Both of these of type length. So I can say apply and say OK. I do want to delete that first joist length. So I'm going to do a couple of things now. One is to make a new sketch using our plane. And what I'll do is I'll make two construction elements and project in these 2 points. And I'm going to draw a simple rectangle. Make sure that this is coincident to that point. And so our top line is green because that's just driven between those 2 lines. I want to add a reference geometry to this. So I'll just double click and say reference. And I want to set the depth of this. And so right now we'll expand the sketch, find our constraints. We want to set joist length equal to 12. And then we're going to set this length. We'll edit formula. We're going to set this equal to the depth. We'll just exit for a second. Joist length. We'll edit this formula and set this equal to joist 12. It tells us it can create a loop, but for the way that we're using it, this will be fine. So we see that we get that value. And for depth, maybe we'll just make something 12 inches so we see where it is now. And again, I want to hide that absolute axis for the sketch. And then I can minimize the sketch as well. So what we need to do now is to create our rule that will drive the depth of the joist based on the overall length. And you can see that we've got the joist length captured here. We just need to set up depth. And so this might be a good time just to save. And we're going to go to a different workbench now. And so we'll go to Start, Project Standards, and Knowledge Advisor. We can see that our icons change, and we're going to go to this little if X then Y icon, which opens a rule editor for us. And so this will be called Rule 1. We could rename it Joist Depth Rule. And say OK. And it's going to open a window for us. We want to do a couple of things now. This just tells us when that rule is created. So I have a couple of dimensions based on a simple span chart. And so what we want to be able to say is if joist length, and so we can just click joist length in the tree and it'll drop it over here. If that's greater than 110 inches, if that's less than or equal to 110 inches, the syntax here is that we use the curly brackets, and then this is the result, so we can say depth is equal to 5.5 inches, and then close the curly brackets. And so we might just cut and paste this down here. But now we want to add something a little bit different. We want to say, well, if joist length is less than or equal to 110 inches, then make that a 2x6. Else if, meaning that if that's not true, then this happens. Then if joist length is greater than 110 inches and joist length is less than 145 inches, we're going to make the depth equal to a 2x8 instead of a 2x6, so that will be 7.25 inches. We can cut and paste this one, and in this case, where we end with 145, we can start with 145, and this will go to 185, and we'll set that one equal to 2x10, which is 9 1/4. We can cut and paste this again. And this time where we ended with 185, we'll start with 185. And this will go, it has to be less than 225. And this will make a 2x12. And so the last one that I want to add, you can imagine we could keep adding these as we go, is that if it's greater than 225, I want to set the depth to be equal to something very small, so that if I know that I'm outside of the range of what's acceptable, then it'll clearly show us that. So I'll say OK. And we can see in relations now, there's a new icon, and there's a joist depth rule. So what I'd like to do is just take that and drag it down to our build geometry, and so that our rule gets created each time we make a new power copy. And so we can exit the workbench now and go back to Project Center Geometry, back to some icons that we're familiar with. We need to now drive the sketch and set well, actually, all we really need to do is to come back. Well, actually, I'm wrong. This is working now. We can see that this is f of x, and so as we get over here, we can exit the sketch and see that this is working, and it's driven by that rule. And so what we might want to do is just test this. Currently, that's 11.25, that's a 2x12. So if we go back to our first sketch in the framework and reduce these numbers down, we don't need to change that number. I can reduce this down. And now we see that the joist length is 149, and it's now a 2x10. And so we know that the rule is working. So I want to just add a couple more surfaces to change this from just a simple 2D abstraction to actually give it a size. And so what I'll do is I'll just use a simple extrude and extrude the sketch. And I'll do that 0.75, but I want to do it in both directions. And 0.75. So if I zoom in, we can see there's the center line, and then the surface is being extruded 3/4 of an inch in both directions, which gives us 1.5 inches. So I can say OK. And then what I'll do is I'll make a fill surface, and I'll just select the edges of that extrude. Once we select all four, then it tells us that's a closed contour. We can say OK. And I'll just swing around to the other side and do the same thing. You'll see what happens once we select one. It tells us that there's an open gap. Once we select two, then it triangulates it. We can select the third. It seems like I selected the surface and not the edge. And so now it's a closed contour. We can say OK. And so maybe just for good measure now, I can hide all of these elements, and then I'm just going to make a join, which is here, of the extrude, the fill, and the other fill. And so now we've just got one join here as a simple representation of that. So now we're at the point where we can create our power copy. And I'll minimize my build geometry. And what we'll do now is we'll go to Insert, Advanced Replication, Power Copy Creation. This will open the Power Copy window. We can name our power copy here. We'll call it Joist. And we need to select our entire build geometry geometrical set, which places that within here. And then what I want to do is I've got two formulas. And right now, we want to, and this is the difference between a global parameter and a localized parameter for each power copy. Right now, this is telling us that we're going to need a point. We're going to need to tell it where the absolute axis system is, and then we're going to need the output. It's also looking for these two parameters to drive the rest of the power copies, and that's not really what we want. So I'm also going to add these two relations within here. And so what this should do, and we'll try it and make sure this is the case, is that we're going to want the relations, and we're actually going to create these things as we go. So we're only going to have 3 inputs. We'll say OK. This now creates a power copy called Joist under here, and we'll try and insert one of these. Before we do that, we want to make a new geometrical set. This is just how I tend to order things. I'm going to call this power copies. We want to make sure that power copies is current. We can say insert, advanced replication, instantiate from selection, and we'll just click on the joist. It's going to give us this window here. And so this, whatever is orange, tells us what it's looking for. It's looking for a point, then an absolute axis system, and then the output. So we can try a point over here. The absolute axis system we can select from the tree, and the output we can select there, and say OK. So now a couple of things have happened. We've added 2 more relations. We've added two more parameters. And we've added another build geo under our power copies. This seems to be working. The joist here is not as deep as the first joist, which would make sense. So what's going to happen as we add subsequent power copies is that we'll add lots of parameters, which is fine, but all of them are controlled by our sketches. We do have to be careful because this defaults to making whatever we just created as a power copy current. We want to go back and make sure that power copy geometrical set is current. We don't want to put a power copy inside of a power copy inside of a power copy. We want all of these things to be at the same level. So we can do one more. Insert, advanced replication, instantiate from selection. Choose joist. And we can choose a different point. maybe at the other side. Absolute axis system. I was trying to avoid having to put in the absolute axis system. It seems like by doing our 3 points, it didn't avoid that. And so now we've got our 3 joists. And so I might just do this a couple more times. I can make power copies current again. Insert this, select joist, say OK. Select the point, absolute axis, and then the line. Say OK. What I'm trying to do is just get enough within here that I have a sense if this is working the way that we want it to. You can see it's an easy enough power copy to insert with just 3 inputs. And so that's seems like enough for me to have a sense if this is working or not. And what I'll do is I can just go into my sketch, I can double click it, zoom, and so now we also can test. This, which was already set, and that was based on our first point. So maybe I'll go to here. I just want to move that point to something like 300 maybe, something beyond what we want that to be. And that's exactly what should happen given our rule that we wanted this to be able to tell us when it was out of the range. So if I go back to the sketch and modify this length, we can see this one is shorter, that one's a little bit longer, and then again we're outside of the range. And so I can go back to my framework and change that point. And now we'll see where that happens again. And that's out of the range here, and this drops down to the lowest point. And our smallest length was 110 within our rule, so if we drop this down to below 110, we should see a full range of options here. Probably our 2x6, something in between, maybe our 2x8 or 2x10, and then all the way over to 2x12. So you can place all of those in as a power copy, and you'll get a sense of how the rule creates the threshold for one condition to happen. It's changed to a different depth and all the way through. And that's just driven by these. In this case, we do not have any global parameters to control anything. All of these parameters we can see are all set and driven by the geometry. And so we can just leave those alone. And I guess the last thing we can do is just look at this from the front, where we can see the depth in relationship to one another. So hopefully this helps clarify some of the issues related to rules and how rules might be able to be used within power copies. So give it a try and let me know if there are any questions.